Hello, Whiteboard Economist here, and welcome back to my channel. This is another video of my series Calculus 1, and the topic for this video is function transformations. Well, what is a function transformation? In a nutshell, it's taking a graph and changing the way it looks by either shifting it, stretching or compressing it, or reflecting it across one of the axes. And you've probably done something like this in geometry class, so this video shouldn't be anything too complicated for you, but I just wanted to go over it again in case if some of you missed something from before, and so let's begin. Well, there are two main types of transformations. The first type is translation. And what a translation is basically a shift of the curve. Let's say you have a curve like this, just any generic curve, and if you wanted to translate it, let's say you wanted to translate it to the right, over here, then you simply just do this. So it's basically a parallel shift of the curve. So this is the graphical representation of a translation, but how would you do it with an equation? Well, let's do that then. Let's say your original equation was f of x. Well, y is equal to f of x. And let's just draw the graph. Let's just use a parabola because parabolas are easy. And easy is good. Okay, so here's your original equation. And say you wanted to translate it c units upwards. You wanted to make it go upwards. C units. So your new graph would just be this. Alright, so how would you write that down in an equation? Well, here's your new equation for this graph. Y is equal to f of x. And since it's an upward translation, plus c. Alright, so now that we did an upwards translation, let's do a downwards translation. Instead of going up c units, you want it to go down d units. So your new graph will be this, right here. So how would you write this one out? Well, since going upwards was plus c, and going downwards naturally will be f of x minus d. Alright, so that's your vertical translations. So next let's do horizontal translations. Okay, so let's get rid of all this right here. Alright, so parabola. Alright, so let's say you wanted to do shift the rightwards, c units. And so your new graph would be this. C units. Alright, so how would you write this out in an equation? Well, you put in function notation. X is f of x, and since this is a horizontal translation, you would change the values inside the parentheses. Alright, c. And since it's a horizontal translation, you would do x minus c. Now I know by looking at the graph, it looks like it will be x plus c because this is a positive change. But for horizontal changes to it, horizontal transformations, everything that you do, you would represent in an opposite way in the function. So a rightward shift to c is actually x minus c. If you wanted to do, let's say y is equal to f of x plus, if you wanted to do an addition inside the parentheses, it will be a leftward shift of d. So this will be your x plus d. So that will be your leftward translation. Alright, so translations are simple enough. It's just simply doing parallel shifts to the curve. The next type of transformations I wanted to talk to you about today is, just let me erase all this right here. They're called reflections. And stretches. Well, by now you probably realize that mathematicians are not exactly the most creative people in naming things, so it'll be very obvious on why these are called reflections and stretches. So let's begin with this. Let's say your original function was y is equal to f of x, and for this one, to illustrate, let's do stretches first. And to illustrate, let's use a cosine curve. Alright, so say you want to do a vertical stretch. Make it bigger vertically by a factor of c. So what would you do? Well, since this is a stretch, you would do a multiplication. So it gives you y is equal to c times f of x. That's a c, not a parentheses. That's a c. Alright, so this is a vertical stretch. To do a vertical compression, which is the opposite of a stretch, see, for a stretch, you stretch it out like this. So what we're going to do now is a compression. So we're going to squeeze it back together. So a compression would just be this. It's a flatter curve, and let's say it's compressed by a factor of d. What would you do? Since a stretch was a multiplication, a compression naturally would just be y is equal to f of x divided by d. So these are your vertical stretches and compressions. So now that we did vertical, let's go on to horizontal stretches. Alright, so again we have your original equation, f of x. For this one, y is equal to f of x. It's not writing correctly. Alright. So for this one, let's do a parabola again, because this one will be easier to represent. Alright, so here's your original equation, the original graph. And let's say you wanted to do a horizontal stretch. So your horizontal stretch right here by a factor of c. Alright, so if you remember from your translations, whatever is horizontal you put inside the parentheses, and whatever you see on the graph, it's opposite of what you put on the equation. So you can probably guess this is y is equal to f of x divided by c. So this will be your horizontal stretch. And to do a horizontal compression, squeeze it back together, let's say by a factor of d, you can probably guess it already. It's y is equal to f of x times d. Alright, so that's all for stretches, and the last thing we want to do is reflections. Well, reflections are pretty straightforward as well. If you've been graphing things, you probably realize that there are two axes in the graph, your x-axis and your y-axis. So there's only two possibilities where you can reflect it. You can either reflect it across y or reflect it across x. So let's say your original equation is this. Y is equal to f of x. So, like I just said, you have two choices. You can either reflect it across the y-axis, like this, or you can reflect it across the x-axis, like this. So, these are the graphical representations, but how would you do them with an equation? Well, let's do the y-axis first. So, reflected across the y-axis, this is a horizontal change, right? You change it horizontally. So, whatever you do to the equation, it goes inside the parentheses. And since everything that was positive now it's negative, you would just simply do f is equal to y is equal to f of negative x. This will be a reflection across the y-axis. For the reflection across x-axis, you can see that it's a vertical change. It's vertical, and anything that was negative, anything that was positive, it becomes negative now, and so you have y is equal to negative f of x. So this will be your vertical reflection, or your reflection across the x-axis. Well, that's all we have for reflections, and that's all we have for this video. Like I said, nothing too complicated, just basic transformations, stuff you've probably done before. But anyway, at any rate, I hope you enjoyed this video and found it at least somewhat informative. And as usual, have a nice day.